All right, this is 8.2.2. We're going to find the area of regular polygons. Remember that we have a formula to find the area of regular polygons. In general, we're using the formula area equals the apothem times the perimeter divided by 2. So if we can find the apothem, or the height of one of the isosceles triangles within this regular polygon, times it by the perimeter of the polygon, and then divide that whole thing by 2, we'll have our answer. So taking a closer look at number 1 and number 2, we need to make sure that in these first problems we use special right triangles to solve these regular polygons, and we leave our answer in reduced radical form, which means that we are going to have a radical or a square root in our answer. The first problem, since I know that this is a regular polygon, I know that this must be a square, because regular polygon, this must be a square. All sides are the same. That means that this must be a 90-degree angle, and all of these sides must be congruent. I know that this guy is the radius of this square, so he must cut this 90-degree into 2 equal sections. That means that I must have a 45-degree angle on this side as well as on the other side. If I go ahead and copy this triangle's down, I have an 11 here and an 11 here. Then if I draw the height down, or the apothem coming down at a 90-degree angle, we see that we have a nice 45, 90. That one must be 45 degrees as well. So if I draw this right triangle again, I have a 45, 90 degree right triangle, and I know the hypotenuse length is 11. Remember, our goal is to use that formula, the area equals the apothem times the perimeter divided by 2. Well, the apothem will be solved for right here. This will give us our apothem. To find the perimeter of this guy, we could use this side, which would equal this side. If we times it by 2, we'd have the entire base, and then if we times that by 4, we'd have the entire perimeter. So I think we have a good strategy to find this. We need to find both the apothem and this base length, and then we can use those numbers in this guy to find the entire area. Well, since I have a special right triangle going on, I think I can avoid trigonometry on this problem. I know that in these special right triangles, I have a basic formula that across from both of the 45-degree angles is x, and across from the 90, or the hypotenuse, is x root 2. So it looks like in this case I am given the hypotenuse, so I need to work backwards or divide by root 2 to get to one of the bases. So I'm going to take that 11 and I'm going to divide it by root 2. Remember, these are not common numbers. They are not the same type of number, so we cannot divide 11 by root 2. Instead, let's go ahead and rationalize this denominator by multiplying by root 2 on both the top and the bottom. On the top, this gives me 11 root 2, and on the bottom, this gives me, since they are like numbers, you are allowed to multiply them. Root 2 times root 2 is root 4, but doesn't square root of 4 just equal 2? Oh, bingo. So now we have our side length. It's 11 root 2 divided by 2. That would be the blue line as well as the red line. Let's bring that back up into our general picture. I now know what my apothem is. My apothem is 11 root 2 over 2. My perimeter, however, this side length gives me this length here. So if I times it by 2, I'd have the entire length. So if I take that number and times it by 2, I would get the entire base length of one of these squares. Well, looking here, I can just cross reduce, so I believe the entire purple length is 11 root 2. That now is just one of these lengths, not the perimeter, just one of these lengths. To get the entire perimeter, I'd have to times it by 4. So if I times 11 root 2 by 4, remember I'm only multiplying like terms, I would get 44 root 2 for my perimeter. And then again, we found our apothem is 11 root 2 over 2. Okay, based on this information, I think we're ready to solve. I know that the area of this entire square equals the perimeter, 44 root 2, times the apothem, 11 root 2 over 2, all divided by 2. Let's look at the top first. If I wanted to multiply this, I could start by cross-reducing here, and I get 22 root 2 times 11 root 2. And then if I go ahead and multiply, I have 22 times 11, which gives me 242. Root 2 times root 2, that gives me root 4, which is just 2. So if I times that by 2, that's what I get on top. And then on the bottom, I have divide by 2. So can't I just cancel these guys out? And I have my my entire area as 242. What is the units here? Oh, we don't have units, so we'll do units squared. Another way you could have solved this is by finding this purple length is 11 root 2. And don't you know the formula for a square? The area of a square is just this times this. So another way we could have solved is that the area would equal 11 root 2 base times height, which is also 11 root 2. Well, 11 times 11 is 121. Root 2 times root 2, that's root 4, which is 2. So 121 times 2 equals 242. That's a little bit easier way to solve. Either way, if you use the formula, area equals apothem times perimeter divided by 2, you get this thing, which reduces. Or if you just use the idea base times height in a square, you'd still get the same answer. Let's look at number 2. Number 2 looks like it's a hexagon. I know that all of the angles in a hexagon have to add up to 720 degrees. And I use that by using last week's idea that the angles sum of a polygon equals 180 times the number of sides minus 2. So that since this is a hexagon, I did 6 minus 2, which is 4 times 180, gives me 720. So all of those angles together give me 720. So to find just one of those angles, if I divide that by the number of equal angles there are, divide that by 6, I get that 720 divided by 6 gives me 120. So each of these angles is 120 degrees each. Then if I take this idea of putting isosceles triangles in, you see that these radii not only are congruent, but they also cut these angles into equal sized pieces. So I'm taking this 120 degree angle and dividing it in 2 again, which gets me 60. So this angle right here is 60 degrees. Then if you drop down your apothem, you start to see that you have this nice right triangle. Let's take that purple right triangle out of the picture to make it a little bit easier to work with. Again, this length here is not the entire 8 base, it's only half of that, which would be 4. This angle here represents this angle here, which is 60 degrees. So if you notice, we must have a 30, 60, 90 degree right triangle. We have a special right triangle, so we can use our little formula. The side across from 30, we consider that to be x. The side across from 90 is 2x, or 2 times that side. And then the side across from 60 is x root 3. So to find these other pieces of the triangle, I have the x piece. I have this piece here. To get the hypotenuse, we just times that by 2. And we get the hypotenuse is 8. To get the Side across from the 60, this side, we have to times by root 3. So we're going to take 4 and times by root 3. So we get 4 root 3. This is wonderful because I think I'm very close to using my formula. Remember, the area equals the apothem times the perimeter divided by 2. Well, I already know my apothem. My apothem, remember, is this line that goes straight down, meets at a 90-degree angle, basically the height of that triangle. So my apothem equals 4 root 3. My perimeter has to be all of the 6 sides added together. So wouldn't that just be that 8 times 6? So my perimeter is going to be 8 times 6, which gives me 48. Now let's go ahead and plug this in. My area then is going to equal my apothem, 4 root 3, times my perimeter of 48, all divided by 2. Let's go ahead and solve on top. Remember, only multiply like terms. So the 4 and the 48, you can multiply those because they're just plain old numbers. You get 192. There is no other root 3 for that guy to play with, so we're just going to leave him alone. And then divide it by 2. Now that you've done this, we can go ahead and reduce. 192 divided by 2 gives me 96. And that root 3 stays where he's at. So the answer here is 96 root 3 units squared. Let's move on to number 3. Now we are rounding our answer to the nearest tenth. I highly suggest that you round your answers in the middle to like the nearest hundredth or even the nearest thousandth, and don't round to the nearest tenth until the very end. Remember, your answers might be a few decimal places off of mine, and that's just because of where you rounded and how you rounded. But as long as you're really pretty close to my answer, then you'll be fine when it comes to test or quiz time. We're going to solve using the same method. We're going to do that area equals apothem times perimeter divided by 2. So in general, I want to know what my apothem is and what my perimeter is, and when we have that, we can go ahead and solve for our area. Right now, there's one thing we can solve for very quickly, and that's perimeter. I know by the directions that this shape is regular, so all of these sides are 7 yards long. So I have 1, 2, 3, 4, 5, 6, 7 of those. So my perimeter is going to be 7 times those 7 sides, or 49 yards long. Now we just need to find the apothem, and we basically have all we need. Let's remember that the apothem comes from the center of the triangle and comes down and meets at a 90-degree angle. So this is what we're trying to find. And once we have that, we have our apothem. We can solve for that using the fact that all of these angles together have to work in that angle sum idea. Remember, the angles of any shape, the sum of those angles has to equal 180 times n minus 2. N is the number of sides. There are 7 sides here. So we're going to do 7 minus 2, that's 5. I'm going to take 180 times 5, and I know all of these angles of this shape have to add to 900 degrees, all of them together. So then to find just one of those angles, I would divide that by 7, and I know that one of the angles is about 128.5 degrees. This whole thing is close to 128.5 or 6 degrees. Again, you're going to be rounding here, which means our answers might be a little bit different based on how you round. So this entire purple angle is 128.6, but I only want to use this half of the angle, the half that's actually within this triangle. So if I divide that answer by 2, I get that the actual angle that I'm working on, this piece of that angle, this red half, the angle I'm actually going to use is about 64.3. Again, rounding might change your answer a tiny bit. So if I go ahead and I draw this triangle, and I like to do this just to make it a little bit neater, I have a right triangle here. I'm looking for this purple line, And when I have it, I basically have what I need, because remember, that's our apothem. I have that the base angle here is about 64.3 degrees, and I have also the base length. Remember, the apothem is going to cut this guy into 2 equal pieces. So this whole base length is 7 yards. That means this half of that must be 3.5 yards. Now we have what we need, and we can go ahead and use trigonometry to solve. I have this angle, which means this side is my opposite, this is my hypotenuse, and this is my adjacent side. Based on the fact that I'm looking for this side and I have information about this side, hypotenuse is not involved. That means I should use tangent, because SOHCAHTOA, tangent involves opposite and adjacent. Opposite and adjacent are what is involved in this problem. So the tangent of an angle always equals the opposite over the adjacent side. So the tangent of this angle, which is 64.3 degrees, must equal the opposite, which is x, over the adjacent side, which is 3.5. To get x by itself, I need to do the opposite of dividing by 3.5, which would be multiplying by 3.5. And if I do that on both sides of the equation, the right side will cancel, leaving me x by itself equals 3.5 times the tangent of 64.3. Now I can turn to my calculator and type it in exactly as written. 3.5 times the tangent of 64.3 gives me about, remember we're rounding, we get something close to 7.272 for x. Remember that x that we just solved for is our apothem. We just found our apothem. So that means I can go back up here and say I know my apothem. It's about 7.272. And now we can go ahead and go after our answer. The area of this shape is going to equal the apothem times the perimeter divided by 2. So if I times my apothem by 49 and I divide that answer by 2, I get that my area is somewhere close to 178.2 yards. If you got somewhere close to 178, you have this answer correct. Remember, you can be a little tiny bit off based on how you rounded within the problem there. All right, we're going to do this process several more times. It's going to be very familiar by the end because it's very repetitive. This problem works with an octagon. I'm going after my area equals perimeter times apothem divided by 2. So I need to know what my perimeter is and my apothem is. I can tell you my perimeter right now is going to be 8 times 8, or 64. The apothem takes more work. Remember, the apothem is this purple line right here. I like to call him X instead of A, just because A gets confusing when you're using adjacent as well. Anyways, to find this apothem, I would use trigonometry, but before I can do that, I need to know what all of these angles are. To remember how to do that, you can either use your chart from a previous lesson, or you know that the angle sum of the angles has to equal 180 times n minus 2. In this case, my n is 8. So if I did 8 minus 2, I'd have 6. So 180 times 6 is 1,080 degrees. All of those angles together is 1,080 degrees. If I divide that by the 8 equal angles that are within this shape, I know that one angle, the entire thing, is 135 degrees. Remember, I'm only using this half of the angle, the half that's actually within my triangle. So if I take that 135 and divide it by 2, I get that that angle inside there is 67.5 degrees. At this point, I really like to draw this shape again just because it got kind of tight in there. I know that I'm trying to find this line, my apothem.
I also know that this angle is 67.5 degrees, and I know that this base length, the entire thing is 8. So the piece that I'm using in this triangle must then be 4. So to solve for this, I'm going to use trigonometry. I have this angle, so this must be my opposite and my adjacent, which means tangent would be a good idea to solve. The tangent of an angle equals the opposite over the adjacent. So the tangent of this angle, which is 67.5, must equal the opposite of x over the adjacent of 4. I want to get my x by itself, so the opposite of dividing by 4 is timesing by 4. So I'm going to times by 4 on both sides, and I have that 4 times the tangent of 67.5 equals x. I can type that into my calculator exactly as written, and I get that x, I'm going to round to 3 or 4 decimal places here, equals 9.6569. I'll do 4 decimal places. Remember, depending on how you round, your answer will vary a little bit from mine, but as long as you're within a couple of decimal units, you'll have it correct. Now we found our apothem. This x, remember, is the apothem. So we found our apothem. We're ready to go after our answer. The area is going to equal the perimeter, 64, times the apothem, 9.6569, all divided by 2. So I actually still have this whole entire number on my calculator. So I'm just going to leave that there, and I'm going to say times by 64, and then I'm going to get an answer, and I divide that by 2, and then I'm really not rounding very much at all. This will give me my final answer rounded to the nearest tenth of 309.0. And this is in miles, so I would say miles squared. As long as you get somewhere close to 309, you know you're doing it right.